Our universe runs on a hidden code that constantly fixes its own errors. This idea of a self-correcting cosmos is not science fiction, but a serious theory that redefines reality itself. By the end of this journey, you will understand the profound clues suggesting our existence is part of a grand, intelligent design. We will investigate why the fundamental forces are so perfectly balanced, and what mysterious mechanisms prevent the cosmos from collapsing into chaos. How do you feel about the possibility that nothing around you is truly random? Think of the universe as the most complex computer program ever written. Its source code is written in the language of physics, a set of fundamental rules that govern everything from the spin of an electron to the expansion of galaxies. But this is not a static, unchanging script. The radical idea of a self-correcting cosmos suggests that this cosmic software contains its own built-in debugging routines. It possesses mechanisms that automatically adjust its own parameters to prevent total systemic failure. This is stability as an active, dynamic process, a constant and intelligent balancing act that prevents the universe from either tearing itself apart or collapsing into a lifeless lump. This concept pulls from the deepest wells of modern science, from the bizarre rules of quantum mechanics to the abstract mathematics of information theory. The legendary physicist John Wheeler pondered a participatory universe, where the act of observation itself seems to play a role in shaping reality. This hints at a profound feedback loop, a dialogue between the cosmos and the consciousness within it. So what does self-correction actually look like on a universal scale? It is far more than simple equilibrium, like a ball resting at the bottom of a bowl. It is an active, almost vigilant process. The most compelling evidence for this lies in the astonishingly precise values of the universe's fundamental constants. Consider the force of gravity. If the gravitational constant were even slightly stronger, all stars would burn through their fuel in a cosmic blink, and planets would be crushed. If it were slightly weaker, stars would never ignite at all. The mass of an electron, the strength of the nuclear forces, every single one of these numbers appears perfectly calibrated, fine-tuned to an impossible degree to allow for the existence of atoms, planets, and life. This is not a passive state of affairs. It behaves like the output of a brilliantly written code, one that continuously runs checks and applies corrections to maintain its intended function, which seems to be the fostering of complexity and ultimately us. This fine-tuning is the first major clue, pointing toward a universe that is not just random but regulated. It forces us to confront a monumental question. Who or what is the programmer? To find the origins of this mind-bending question, we must travel back in time. This ancient intuition of a structured cosmos runs deep in human history. Long before we had telescopes or particle accelerators, philosophers were already pondering a universe built on reason. Plato argued that the messy world we see is just a shadow of a higher reality, a realm of perfect geometric forms and mathematical ideals. For him, the stars and planets moved in divine circles because the circle was the most flawless shape, a reflection of this underlying cosmic order. This was not a universe of chaos, but one of profound and beautiful logic. That search for harmony evolved through the ages, from mythological stories of gods bringing order from primordial chaos to the scientific revolution that gave us Isaac Newton. Newton's laws painted the cosmos as a vast, predictable clockwork, a magnificent machine where every action had an equal and opposite reaction, and the future could, in principle, be calculated from the present. It was a universe governed by unbreakable, deterministic laws. Then came the 20th century, and our understanding was shattered and remade. Einstein's theory of relativity warped the very fabric of space and time, while quantum mechanics revealed a subatomic world buzzing with probability and uncertainty. Interestingly, Even Einstein inserted a fudge factor into his equations, a cosmological constant, because he too believed in a static, stable universe that should not collapse or run away. He later called it his greatest blunder, but the idea itself was a powerful testament to the belief in cosmic self-regulation. This thread connects thinkers across time. Gottfried Leibniz proposed that our world is the best of all possible worlds, optimized by a divine programmer for maximum variety and richness. In our own era, physicist Lee Smolin put forward a daring theory of cosmological natural selection, suggesting that universes themselves can reproduce, with the laws of physics evolving over countless generations to produce stable, long-lived offspring like our own. From ancient myths to cutting-edge cosmology, the pattern is unmistakable. Humanity has persistently sensed a deep, underlying logic to existence. We have always been searching for the purpose in the cosmic architecture, a design that seems to whisper of something more than mere accident. This historical backdrop is crucial because it shows that our modern question is not a new one. We are simply asking it with new tools and new evidence. That cosmic library, filled with every possible book of physical laws, presents us with a staggering implication. Our existence as observers is not a random accident within the cosmos, but a fundamental feature of it. The Anthropic Principle transforms our perspective from asking why the universe is the way it is, to realizing that a universe capable of asking that question must be structured in a very specific way. The weak version of this principle is a simple statement of selection bias. We find ourselves in a universe with the right conditions for life because, obviously, we could not find ourselves in one that lacked them. It is the ultimate example of survivorship bias, but the strong anthropic principle pushes further, suggesting the laws of physics themselves are in some sense required to give rise to conscious life. This is not just a lucky coincidence, it is a fundamental property of reality. The principle acts as a powerful lens, focusing our attention on the specific, razor-thin sliver of reality we inhabit. It forces us to look at the numbers. Take the cosmological constant, the value that governs the energy density of empty space and the acceleration of the universe's expansion. Calculations show that if this number were just 1 part in 10 to the 120th power larger or smaller, the universe would either have ripped itself apart instantly or collapsed back on itself long before galaxies could ever form. This is a level of precision that defies all ordinary comprehension. It is like throwing a dart from one side of the observable universe and hitting a bullseye 1 millimeter wide on the other side. The same impossible precision applies to the force that binds atomic nuclei together. If the strong nuclear force were even 2% stronger, all the hydrogen in the early universe would have fused into helium, leaving no water or fuel for stars. If it were 2% weaker, complex elements essential for planets and life would never have formed at all. We are left with two profound, and perhaps unsettling, possibilities to explain this immaculate tuning. One is the multiverse, a vast and perhaps infinite ensemble of universes, each with its own random set of physical constants. In this cosmic lottery, we simply happen to live in one of the very few winners, the rare bubble where the numbers came up right for life. The other possibility is that there is a deeper reason, a fundamental law or a guiding principle that mandates a life-permitting cosmos. This second option leads us directly to the heart of the self-correcting code. Could these perfectly balanced constants be the output of a cosmic feedback loop, a system that continuously adjusts its own parameters to maintain stability? The Anthropic Principle does not answer this question, but it frames it with breathtaking clarity. It tells us that our existence is a data point, a clue written into the very fabric of space-time. To ignore this clue is to ignore the most fundamental fact of our reality. The precision of these numbers is so extreme it borders on the absurd. Take the cosmological constant. the value controlling the energy of empty space itself. It is fine-tuned to 1 part in 10 to the power of 120. To even write out that number would require more zeros than there are atoms in the entire observable universe. If this dial were turned up by the tiniest conceivable fraction, the force of dark energy would have been so powerful that it ripped spacetime apart in the first instant of the Big Bang, scattering any potential for matter and life into a thin, cold, eternal fog. Turn it down just as slightly, and gravity would have won, pulling the entire cosmos back into a superheated crunch before the first star ever flickered. This is not a gentle suggestion of balance, it is a scream of impossible perfection. The same razor's edge applies to the forces that build our world. The ratio of the electromagnetic force to gravity is perfectly set for stars like our Sun to exist. Increase the strength of electromagnetism relative to gravity, and stars would burn their fuel in a furious flash, lasting only millions of years instead of billions, leaving no time for planets to cool and life to evolve. Weaken it, and stars would fail to ignite altogether, leaving the universe in perpetual darkness. Even the mass of the most fundamental particles, the quarks, is set to a specific value that allows for stable protons and neutrons. If the quark mass were different by a mere few percent, the complex atomic nuclei that make up our bodies and our world would be impossible. This is not one lucky break. It is a chain of interdependent miracles. Each constant is a keystone in a vast arch, and if you disturb any one of them, the entire structure of a life-permitting universe comes crashing down. How can we explain this coordinated perfection? One answer is the multiverse, a cosmic casino with an infinite number of universes, each rolling its own set of physical laws. We simply find ourselves in the one jackpot universe where every single dial happened to be set just right. The other, more profound possibility is that these constants are not randomly set initial conditions, but are instead the dynamic output of a deeper process. They are the stable, self-correcting solution to the equation of existence, maintained by a cosmic code that actively resists chaos and collapse. This leads us directly to the role of entropy, the measure of disorder, and its strange, one-way arrow that points from the past into the future. That cooling cup of coffee is a tiny window into the most relentless law in the cosmos. Its warmth dissipates into the room, never to spontaneously return, because the universe possesses a one-way street called entropy. Entropy is the measure of disorder, and the second law of thermodynamics dictates that in any isolated system, it must always increase. This is the arrow of time itself, the reason we remember the past but not the future, the force that scatters ink in water and turns stars to dust. Yet this presents a paradox of staggering proportions. If disorder always grows, then the universe must have started in a state of unimaginable order. The Big Bang was not a chaotic explosion, but an event of incredibly low entropy, a pristine, highly organized beginning from which all complexity has since unfurled. This initial condition is yet another example of cosmic fine-tuning, a razor's edge more precise than any we have yet encountered. A random starting state would almost certainly have been one of maximum entropy, a bland, featureless soup where nothing interesting could ever happen. Instead, we got a cosmos primed for creation. This carefully set low entropy is the reason galaxies could condense, stars could ignite, and planets could form. It is the reason you have a past to remember and a future to anticipate. It is the foundational allowance for history itself. Could this be a key function of the self-correcting code? A mechanism that established this perfect initial condition, winding up the cosmic spring so it could unwind over billions of years, creating a long, stable runway for life to emerge. Some physicists propose that black holes, the ultimate agents of disorder, might paradoxically play a role in regulating this cosmic budget, acting as sinks that manage the flow of entropy. Others envision a cyclical universe, where the cosmos undergoes endless cycles of expansion and contraction, with each new Big Bang resetting the entropy clock, a perpetual reboot of the cosmic program. The management of entropy is not a side effect. It is central to the universe's ability to host the long, slow dance of complexity. And as we consider these vast timelines, our attention is drawn to the mysterious forces now governing the cosmic stage, the twin enigmas of dark energy and dark matter. The universe is not just expanding, it is accelerating. This discovery, which earned a Nobel Prize, revealed a repulsive force permeating the vacuum of space itself, a mysterious influence we call dark energy. It is the dominant component of our cosmos, making up about 68% of everything. Yet, we have no idea what it actually is. We only see its effects, a kind of cosmic anti-gravity pushing galaxies apart from one another at an ever-increasing rate. The balance of this force is as critical as any other constant. If dark energy were significantly stronger, its repulsive push would have overwhelmed the pull of gravity in the universe's infancy, preventing any galaxy, star, or planet from ever clumping together. The cosmos would be a cold, thin, and lonely void. If it were much weaker, gravity would have won the cosmic tug-of-war long ago, pulling everything back into a fiery big crunch. Instead, the observed strength of dark energy is perfectly poised to allow for a long, rich, and evolving cosmic story. It gave gravity just enough time to weave galaxies and stars, and then it gently took over, ensuring the universe expands forever without being torn apart too soon. This precise calibration is a hallmark of regulation. Could dark energy be a dial in the cosmic control room, a component of the self-correcting code that actively manages the expansion rate? Some theoretical models suggest dark energy is not a static force, but one that evolves, its strength changing in response to the density of matter in the universe. This would be a true feedback loop, a dynamic conversation between the contents of space and the expansion of space itself, constantly fine-tuning the conditions for complexity. It acts as a cosmic throttle, ensuring the universe does not collapse into itself or fly apart into nothingness, but maintains a stable, life-permitting trajectory for billions of years. But to fully understand the cosmic architecture, we must look at the other invisible hand shaping the universe, the enigmatic presence of dark matter. There is an invisible architecture woven into the cosmos, a hidden framework that holds the light of galaxies together. This is dark matter, the universe's gravitational skeleton. It makes up roughly 27% of everything, yet it does not interact with light in any way. It neither emits, absorbs, nor reflects it. We cannot see it, but we can see what it does. Look at the way spiral galaxies spin. The stars on the outer arms whip around at nearly the same speed as those near the core, a motion that defies the rules of gravity if only visible matter were present. It is as if each galaxy is embedded within an immense, unseen halo of mass, a gravitational glue that keeps it from flying apart. This ghostly presence also acts as a cosmic lens, warping the fabric of spacetime so dramatically that it bends the light from distant galaxies behind it, creating shimmering arcs and mirages in the deep field. Without this dark scaffolding, our universe would be a profoundly different place. In the chaotic aftermath of the Big Bang, ordinary matter alone was too turbulent, too energetic, to clump together into the seeds of galaxies. Dark matter provided the necessary gravitational anchor, a calm, steady pull that drew atoms together, allowing the first grand structures to coalesce from the primordial fog. The amount of dark matter and its specific distribution appear to be perfectly calibrated. Too much, and the universe would have collapsed long ago under its own weight. Too little, and galaxies never would have formed at all. It exists in a golden mean, creating stable halos that cradle galaxies, providing the stable environments where billions of stars can be born, and planetary systems can slowly assemble. This is not a passive backdrop. Some theories suggest dark matter might be more dynamic than we think, with its particles interacting in subtle ways that could help regulate the rate of star formation, preventing galaxies from burning out too quickly or from remaining dark forever. The intricate dance between the visible and the invisible is a masterclass in cosmic balance. But if dark matter provides the grand scaffolding, what about the smallest scales of reality? This gravitational harmony inevitably draws our gaze downward, into the bizarre and probabilistic heart of the quantum world. The same ghostly scaffolding that holds galaxies together finds its echo in the bizarre heart of the atom itself. Here, in the quantum realm, the solid, predictable universe we know dissolves into a cloud of pure potential. A single electron is not a tiny, hard ball orbiting a nucleus. Until you measure it, it exists in a blur of all possible positions and states at once, a condition known as superposition. It is only in the act of observation that this cloud of probability collapses into a single, definite reality. This strange behavior is governed by rigorous mathematical laws, like the Schrödinger equation, which describes how these probabilities wave and evolve over time. Yet, there is a fundamental limit to our knowledge, expressed by the uncertainty principle. You can never know both a particle's exact position and its exact momentum at the same time. The more you pin down one, the more the other becomes a blur. This is not a limitation of our instruments, it is a built-in feature of reality. The most common explanation, the Copenhagen interpretation, suggests that reality does not truly exist in a definite state until it is observed. This places consciousness in a strangely intimate dance with the cosmos, as if the universe requires a witness to bring it into full focus. An alternative view, the many worlds interpretation, proposes a different solution. It suggests that every quantum possibility actually happens, but in a constantly branching multitude of parallel universes. In one branch, the electron is here, in another, it is there, and the entire cosmic story splits in two, creating an infinite tapestry of alternate realities. At its core, quantum mechanics introduces a fundamental randomness, a dice roll at the foundation of everything, yet this randomness is not chaotic anarchy. It is bounded by strict, predictable statistical laws that ensure the stability of every atom in your body. The very chemistry of life depends on this delicate balance. It is the reason electrons occupy stable shells around atomic nuclei, allowing for the complex bonds that build molecules. This exquisite tension between chance and law could be a masterstroke of the self-correcting code. By building a layer of probabilistic freedom into the system, the universe gains the capacity for innovation and variation, for exploring countless possibilities. But it does so within a framework of ironclad rules that prevent total disintegration, maintaining the overall coherence necessary for a cosmos that can learn and evolve. We see the creative power of this quantum randomness etched across the sky. The faint ripples in the cosmic microwave background, the afterglow of the Big Bang, are believed to be the magnified fingerprints of primordial quantum fluctuations. Tiny, random jitters in the energy field of the infant universe were stretched to astronomical scales, becoming the gravitational seeds for all the galaxies, clusters, and vast cosmic voids we observe today. In this breathtaking process, microscopic probability blossomed into macroscopic structure. The universe used its own inherent uncertainty to write the blueprint for everything. This challenges the old, clockwork view of a deterministic cosmos, replacing it with a reality that corrects and creates itself through quantum processes, a dynamic system that writes its own story as it unfolds. This creative leap from the infinitesimally small to the astronomically large was not a slow crawl, but a violent, explosive growth spurt that occurred in the very first instant of time. That explosive leap from quantum jitters to galactic seeds required a mechanism of unimaginable power. The universe underwent a growth spurt so violent it defies all intuition. In the first sliver of a second after the Big Bang, a period known as cosmic inflation, all of space itself expanded faster than the speed of light. This was not a gentle swelling, but an exponential explosion, doubling in size again and again in a fleeting instant. This single idea solves some of the greatest puzzles in cosmology. It explains why the universe is so remarkably uniform in all directions. The cosmic microwave background, the leftover heat from the Big Bang, has almost exactly the same temperature everywhere we look. Without inflation, regions of the universe on opposite sides of the sky could never have exchanged heat or information to achieve this perfect equilibrium. They were simply too far apart. Inflation solves this by stating that these distant regions were once intimately connected, part of a tiny, pre-inflationary patch that was stretched to become the entire observable cosmos. This rapid smoothing also left the universe geometrically flat. Space is not curved back on itself in a giant cosmic sphere, nor is it saddle-shaped and flying apart. On the largest scales, the geometry of the universe is perfectly flat, a critical balance point between expansion and collapse that allows for a long and stable existence. The most profound consequence of inflation, however, is its connection to the quantum world. The microscopic quantum fluctuations that bubbled in that primordial energy field were suddenly stretched to astronomical proportions. Those tiny ripples in the fabric of spacetime became the gravitational seeds for everything we see today. The slightly denser regions pulled in more matter, eventually growing into the vast cosmic web of galaxies and galaxy clusters. The entire large-scale structure of our universe was imprinted by quantum randomness and magnified by inflationary expansion. Yet the parameters of this inflation appear to be set with impossible precision. The duration of this hyper-expansion, the energy scale at which it occurred, every detail seems perfectly calibrated. If inflation had lasted just a fraction longer, the universe would have been stretched into an impossibly thin, cold, and empty void, with matter scattered so thinly that no galaxy could ever form. If it had ended too soon, the cosmos would have remained a dense, hot soup, quickly collapsing back under its own gravity. The energy driving the expansion had to be just right, a golden mean that created a universe balanced on the knife's edge of viability. This precise setup feels less like a lucky accident and more like the output of a calibrated process. Could cosmic inflation itself be a primary function of the self-correcting code? A universal reset button that ensures every new cycle, or every bubble universe in a vast multiverse, begins with the perfect initial conditions for a long and fruitful evolution. Some models suggest that inflation is not a one-time event, but an eternal process, continuously giving birth to new bubble universes, each with slightly different physical laws. In this cosmic landscape, we simply inhabit one of the rare bubbles where inflation tuned the dials correctly. The inflationary paradigm provides a breathtakingly elegant explanation for our universe's large-scale smoothness and its rich, detailed structure. It bridges the quantum and the cosmic, setting the stage for the next great act, the forging of the very first elements from a cooling, expanding fireball. Those first few minutes of cosmic history were a crucible of unimaginable heat and pressure. The entire universe was a nuclear fusion reactor, blazing at temperatures of billions of degrees. In this primordial inferno, protons and neutrons danced a frantic ballet, colliding and clinging together to form the first atomic nuclei. This is the epoch of Big Bang Nucleosynthesis, the universe's first and greatest act of alchemy. In mere minutes, it forged almost all the hydrogen and helium that would ever exist, along with a tiny trace of lithium. But this process was a race against time, governed by two critical factors: the expansion rate of the universe itself, and the precise density of those fundamental particles. The outcome of this race was exquisitely sensitive. The observed cosmic abundances, about 75% hydrogen and 25% helium by mass, match our theoretical predictions with stunning accuracy. This success is a cornerstone of modern cosmology, a powerful verification that our understanding of the universe's infancy is correct. Yet this agreement only holds if the fundamental constants were set to their exact, observed values from the very beginning. The strength of the strong nuclear force, the glue that binds atomic nuclei, had to be perfect. If this force were just a few percent stronger, nearly all the hydrogen would have fused into helium, leaving no fuel for the first stars to ever shine. If it were slightly weaker, fusion would have failed entirely, and the universe would have remained a barren sea of individual protons, with no complex atoms, no chemistry, and no possibility for life. This is not a gentle suggestion of fine-tuning, it is a thunderous declaration. The successful outcome of nucleosynthesis points to a universe that was calibrated from the outset. Its initial conditions and fundamental forces perfectly aligned to produce the specific raw materials required for a future rich with stars and planets. This primordial alchemy provided the universal building blocks. Every star, every planet, and every molecule in your body is made from atoms forged in those first explosive minutes, or in the hearts of stars that came later. The hydrogen in the water you drink is a relic of the Big Bang itself. This flawless production of the light elements feels like the output of a master script, a segment of the self-correcting code that ensured the cosmic inventory was stocked with the correct ingredients for all that was to follow. It set the stage for the next great act of creation, the life and death of the very first stars. Those first stars were cosmic alchemists of a far grander scale. Deep within their searing cores, a new chapter of creation began. Under crushing pressures and temperatures of millions of degrees, the primordial hydrogen and helium from the Big Bang were fused into heavier elements. This is stellar nucleosynthesis, the process that forges the very stuff of planets and life. It begins when two helium nuclei, known as alpha particles, collide to form a highly unstable form of beryllium. Under normal circumstances, this beryllium would break apart almost instantly. But in the heart of a star, a third alpha particle can slam into it before it decays, miraculously forming a stable carbon nucleus. This is the famous triple alpha process, and it hinges on a detail of breathtaking precision. The carbon nucleus possesses a specific, resonant energy level that perfectly matches the combined energy of the three colliding helium nuclei. This resonance acts like a key fitting a lock, dramatically increasing the probability of carbon formation. If this energy level were just 0.5% higher or lower, the reaction would fail. The universe would be devoid of carbon, and with it, the possibility of carbon-based life. Oxygen, another essential element for life and water, is formed in a similarly delicate dance, its abundance also dependent on a finely tuned nuclear resonance. The existence of these elements is not a given, it is a consequence of nuclear constants set with what appears to be purposeful accuracy. This stellar balancing act is governed by a constant tug of war. Gravity relentlessly pulls the star's immense mass inward, creating the extreme conditions necessary for fusion. The energy released by that fusion then generates an outward radiation pressure, pushing back against gravity's crush. For most of a star's life, these two titanic forces exist in a stable equilibrium, allowing the star to shine steadily for billions of years. The star becomes a regulated furnace, its size and lifespan dictated by the perfect balance of fundamental forces. When a massive star exhausts its nuclear fuel, this balance shatters catastrophically. Gravity wins in a fraction of a second, causing the star's core to collapse and then rebound in a titanic supernova explosion. This stellar death is a creative act of unparalleled violence. The blast scatters the star's newly forged elements carbon, oxygen, silicon, and iron across interstellar space, seeding vast clouds of gas and dust with the raw materials for new solar systems. This is the cosmic recycling program, a cycle of stellar birth, death, and rebirth that enriches the galaxy with each generation. The frequency of these supernovae appears to be perfectly calibrated. Too many, and emerging planetary systems would be routinely sterilized by radiation. Too few, and the galactic environment would remain impoverished, lacking the heavy elements needed to form rocky planets like Earth. Could this cycle itself be a function of the self-correcting code? A mechanism that regulates star formation and supernova rates to ensure a continuous, but not overwhelming, supply of life's building blocks. This stellar generosity, this scattering of cosmic ingredients, sets the stage for the next miraculous act, the assembly of these elements into complex, living worlds. This cosmic scattering of elements sets the stage for an even more intricate dance of construction. Around newborn stars, vast disks of gas and dust begin to swirl, a chaotic whirlwind of potential. Within this protoplanetary disk, microscopic particles of ice and rock perform a slow, stately waltz. Drawn together by static electricity and gentle collisions, they stick, forming ever larger clumps. These planetesimals, the building blocks of worlds, continue to gather mass, their growing gravitational pull sweeping up more and more of the surrounding material. This entire delicate process is exquisitely sensitive to the initial conditions. The mass of the central star dictates the temperature and density of the disk. The local galactic environment, whether calm or turbulent, can either nurture this process or disrupt it entirely. And crucially, the abundance of those heavier elements forged in prior stellar generations determines whether the resulting planets will be barren, gaseous giants, or rocky worlds rich with mineral diversity. The outcome of this grand construction project is not random. It appears to be channeled toward a specific, remarkable possibility. Within each system, a narrow band exists where the temperature is just right, not too hot and not too cold, for liquid water to pool on a planet's surface. This is the habitable zone, the cosmic sweet spot. A planet forming within this region becomes a potential cradle, a vessel awaiting the spark of life. The prevalence of such worlds depends on a cascade of fine-tuned factors. Our own solar system seems to be a masterpiece of this architectural principle. The gentle, stable light of our Sun provides a consistent energy source. The rocky inner planets, including Earth, formed within that precious liquid water zone. And notably, the outer giants, particularly Jupiter, act as a gravitational shield. Its immense bulk draws in or deflects countless comets and asteroids that would otherwise bombard the inner planets, preventing a constant state of catastrophic sterilization. This is not a passive arrangement. It behaves like a highly optimized system, with components working in concert to create and maintain a stable environment. Could this intricate choreography be more than a fortunate accident? The distribution and characteristics of planets, from their orbital stability to their atmospheric composition, appear to follow patterns that maximize the chances for habitability. This points toward a profound possibility. The self-correcting code may extend its influence to the very architecture of solar systems, fostering environments where life can not only emerge, but also persist and evolve over geological timescales. The growing discovery of Earth-like planets orbiting other stars only deepens this mystery. Each new world found in a habitable zone raises the same haunting question with greater urgency. Is life a rare statistical fluke, or is it an intended outcome, a feature written into the cosmic script from the very beginning? That leap from sterile chemistry to living organism is perhaps the most profound transition in cosmic history. On the early Earth, a planet still cooling from its violent formation, non-living elements began to assemble in shallow tides and deep sea vents. They formed increasingly complex chains of molecules, a primordial soup experimenting with structure and function. Then, at a moment lost to deep time, a system arose that could not only maintain itself but could also replicate. The first life was born. The speed of this emergence is a powerful clue. Geological evidence suggests life appeared on Earth as soon as it was remotely possible, the moment the planet was no longer a molten hellscape. This rapid genesis implies that given the right cosmic ingredients and stable conditions, the spark of life may not be a fantastically rare accident, but a probable, almost inevitable, outcome of the universe's own evolutionary rules. The laws of physics and chemistry seem to permit, and even encourage, this progression toward complexity. They allow for the formation of intricate information-storing molecules like DNA, a code written in just 4 chemical letters that can guide the construction of an entire organism. They allow for proteins, molecular machines that carry out the endless tasks of metabolism and repair. Life, at its core, is information that has learned to persist and perpetuate itself. Then comes the second, even more staggering leap. From this swirling dance of biological information, consciousness emerges. A living thing becomes aware of its own existence. It can perceive the world, form thoughts, and ask questions about its own origins. We Are the Universe becomes self-aware, a collection of ancient stardust now contemplating the stars from which it came. This self-reflection may not be a mere byproduct. Some interpretations of quantum mechanics, like the Copenhagen interpretation, suggest that the act of observation is what collapses the wave function, transforming a blur of probabilities into a definite reality. In this view, consciousness is not a passive spectator but an active participant in shaping the cosmos. This idea blossoms into the participatory anthropic principle, a concept that takes the fine-tuning of the universe to its logical and breathtaking conclusion. It proposes that the universe is structured to give rise to observers because observers are required to bring the universe into full being. We are not just lucky inhabitants of a life-friendly cosmos. We are an essential feature of its very existence, the mechanism by which the cosmos can know and experience itself. This transforms information from a simple abstraction into a potential fundamental component of reality, as vital as space, time, and matter. The code of life and the mind that reads it could be the ultimate expression of the universe's self-correcting nature, a recursive loop where reality creates the conditions for its own comprehension. This computational view of the cosmos transforms every star and atom into a day, a point in a cosmic calculation. The legendary physicist John Archibald Wheeler captured this with his famous phrase, "it from bit." He proposed that every particle, every field of force, even space-time itself, derives its existence from binary answers to yes or no questions. In this radical vision, the bedrock of reality is not energy or matter, but information. The laws of physics are not just passive descriptions. They are the active algorithms of a universe-sized processor. Gravity, electromagnetism, even the bizarre rules of quantum mechanics, are the subroutines of a grand cosmic program, and the reality we experience is the stunningly rich output. This perspective resolves one of the most perplexing puzzles in theoretical physics, the black hole information paradox. When something falls into a black hole, it seems to be erased from existence, lost forever. But the principles of quantum mechanics insist that information can never be truly destroyed. This is a fundamental rule of the cosmic code. The paradox suggests our understanding is incomplete, hinting that the information is not lost but preserved in some way, perhaps encoded on the black hole's event horizon. This is a powerful clue that the universe operates like a perfect computational system, one that rigorously conserves data. This principle of data integrity finds a direct parallel in our own technology. The digital files on your computer are protected by error-correcting codes. These are clever algorithms that detect and fix flipped bits, ensuring a photo or document remains uncorrupted over time. Could the self-correcting mechanisms of the cosmos work in a similar way? The mind-boggling fine-tuning of physical constants, the precise balance of forces, these could be the universe's own error-correcting protocols in action. They are the dynamic routines that constantly check the cosmic computation, making subtle adjustments to prevent a fatal crash into chaos or collapse. This idea finds its ultimate expression in the holographic principle. It proposes that all the information describing everything within a three-dimensional volume of space, every star, every planet, every person, is actually encoded on a two-dimensional surface that surrounds it, like a cosmic hologram. The world we perceive in three dimensions is a projection from this vast informational surface, much like a three-dimensional movie is projected from a two-dimensional screen. Your entire lived experience in this view could be information stored on the boundary of the observable universe. If the universe is fundamentally a computer, then its long-term stability is its most critical function. It must run its program without crashing for billions of years. This necessity for robust, error-resistant operation leads our gaze toward the most profound cosmic reset of all. The possibility that the universe is not a one-time event, but part of an endless cycle of creation and destruction. The ultimate form of error correction might not be a patch, but a complete system reboot. Envision a cosmos that does not simply expand into cold oblivion, but one that breathes, inhaling after a long, slow exhale. This is the vision of a cyclical universe, where a final big crunch collapses all matter and energy back into a singular state, only to be reborn in a subsequent Big Bang. In this endless rhythm of cosmic death and rebirth, the perfect fine-tuning of our universe is not a one-in-a-trillion miracle, but the result of countless trial runs. Each cycle could be a chance to reset the dials, a grand-scale self-correction mechanism where the laws of physics themselves are subtly retuned. Imagine a cosmic natural selection operating across eons. Universes that, by random chance, develop stable parameters that allow for long-lived expansion, and the formation of complexity are the ones that successfully reproduce through their cyclical rebirth. Those with flawed constants that lead to immediate collapse or sterile emptiness simply end their lineage. Over infinite cycles, the cosmos would naturally select for the very conditions we observe, evolving toward universes optimized for longevity and richness. The ekpyrotic scenario from string theory offers a different but equally mesmerizing version of this renewal. It proposes our Big Bang was not a singular emergence from nothing, but a colossal collision between two multidimensional membranes existing in a larger reality. This cosmic collision resets the universe, wiping the slate clean and beginning a new expansion phase, potentially with slightly different physical laws each time. These cyclical models shatter our linear perception of time. There is no single beginning and no absolute end, only an eternal, dynamic process of renewal and learning. The fact that our universe appears so perfectly calibrated for life could be read as a cumulative achievement, the hard-won wisdom of countless cosmic iterations encoded into the very fabric of reality. While definitive evidence for these cycles remains beyond our current grasp, they provide a profound and elegant framework for understanding the universe's most baffling feature, its immaculate design. This transforms existence from a fleeting accident into a potentially eternal story. Guiding this eternal story are the most unbreakable rules in the cosmic code, the profound symmetries that dictate nothing can ever truly be lost. These unbreakable rules are written in the language of symmetry. Look at a perfect snowflake or a spiral galaxy, and you feel an innate sense of balance and harmony. This aesthetic beauty is a shadow of something far deeper, a set of foundational principles that govern every interaction in the cosmos. In physics, symmetry means that a law remains unchanged under a transformation. Rotate a circle and it looks the same. This simple idea, when applied to the universe, yields its most powerful and unchanging laws. The brilliant mathematician Emmy Noether proved a stunning connection. She showed that for every continuous symmetry in nature, there is a corresponding conservation law, a quantity that can never be created or destroyed. The symmetry of time translation, the fact that the laws of physics are the same today as they were yesterday, leads directly to the conservation of energy. The total amount of energy in the universe is constant forever. The symmetry of spatial translation, the idea that physics works the same here as it does in a distant galaxy, gives us the conservation of momentum. An object in motion stays in motion. The symmetry of rotational invariance gives us the conservation of angular momentum, the force that keeps a spinning ice skater twirling faster as she pulls in her arms. These are not just interesting observations. They are the ironclad grammatical rules of reality, ensuring that cause always precedes effect and that the cosmic equations always balance. Without them, the universe would be a lawless, unpredictable place where logic itself would fail. But how does a universe of perfect symmetry create the stunning diversity we see around us? The answer lies in a process called symmetry breaking. Imagine a perfectly round, perfectly balanced pencil standing on its tip. This state has the highest possible symmetry, but it is also profoundly unstable. The slightest breath of air, the tiniest vibration, will cause it to fall, choosing one specific direction. The perfect symmetry is broken, and in that breaking, a specific reality emerges. This is precisely what happened in the early universe. A fraction of a second after the Big Bang, a field known as the Higgs field underwent a cosmic symmetry break. Before this moment, all fundamental particles were massless, zipping through the newborn cosmos at the speed of light. As the universe cooled, the Higgs field settled into a new state, and in doing so, it endowed certain particles with the property of mass. This was the moment matter gained substance, the moment particles could slow down and clump together to form atoms, stars, and us. The underlying laws remained perfectly symmetrical, but their manifestation in our reality required a broken symmetry to generate the rich tapestry of the world. This interplay is a masterstroke of the self-correcting code. The fundamental symmetries provide the unwavering, error-resistant foundation, the bedrock upon which everything is built. The symmetry breaks then introduce the necessary variation and complexity, all while operating within the safe, predictable boundaries set by those conservation laws. This ensures the system can be both stable and creative, both lawful and diverse. Nowhere is this principle of unwavering constancy more absolute than in the conservation of information. In quantum mechanics, information is never truly lost. If you burn a book, the ash and smoke seem to have erased its story. But in principle, with a godlike knowledge of physics, you could reverse the process, gathering every particle of smoke and ash to reconstruct every word. The information was merely scrambled, not destroyed. This is why the black hole information paradox was so troubling, because it seemed to violate this most sacred of cosmic rules. The potential resolution, that information is preserved on the event horizon, is a powerful testament to the universe's commitment to data integrity. It will not allow a paradox to crash the system. The persistence of these symmetries and their corresponding laws for over 13 billion years is the strongest possible evidence for a robust architectural plan. They are the non-negotiable constants in the cosmic algorithm, the error-correcting protocols that prevent the calculation from ever going astray. They allow for near-infinite complexity, just as the strict rules of grammar allow for near-infinite poetry, all without descending into meaningless noise. This flawless, persistent execution inevitably forces us to ask about the processor running this magnificent code. What are the ultimate limits of this cosmic computer? And what does its inherent complexity reveal about the nature of existence itself? Every cosmic computer has a finite memory. The universe itself is no exception, bound by a fundamental limit known as the Bekenstein bound. This principle states that any region of space can only contain a finite amount of information, directly proportional to the area of its surface, not its volume. There is a maximum amount of data that can be stored within a given volume, a cosmic memory cap. This is not a limitation of our technology, but a built-in feature of reality itself, a firewall against infinite regress and unresolvable paradoxes that could crash the entire system. It means the cosmos operates within a defined budget, a set of constraints that prevent its computations from spiraling into nonsense. Within this finite memory, the self-correcting code must work with breathtaking efficiency. It cannot simply brute force its way to complexity. It must optimize its processes to create the richest possible outcomes from limited resources. This is why we see the same elegant patterns repeating at every scale, from the branching of a tree to the vast structure of a galactic cluster, and from the flow of water to the intricate connections of a neural network in the brain. These are not coincidences, they are the signature of an efficient algorithm, a code that reuses its most successful subroutines to build layers of emergent complexity without exceeding its processing allowance. This dance between order and chaos is perfectly choreographed. Chaos theory reveals that simple, deterministic rules can generate behavior of stunning complexity and apparent randomness. A double pendulum moves with unpredictable, wild swings, yet its motion is confined within a bounded shape known as a strange attractor. It is chaotic, but not lawless. The universe employs this same principle on a grand scale. It uses simple, elegant laws as a foundation, then allows for chaotic, probabilistic processes to explore near-infinite possibilities, all while strange attractors, like the fundamental constants and conservation laws, keep everything within viable, life-permitting parameters. This balance is the secret to a sustainable cosmos. It fosters endless innovation and novelty, ensuring the cosmic story is never boring or static. Yet it maintains an overarching stability that prevents a descent into pure noise or rigid, sterile order. The universe is a master of maximizing complexity within its constraints, a system that thrives on the creative edge between predictability and surprise. This intricate management of information and complexity inevitably draws our own consciousness into the equation. We are not just passive observers of this cosmic computation, we are active participants within it, nodes in the network that have become aware of the code itself. Your own awareness, that inner voice reading these words, might be more than a ghost in the machine. What if consciousness itself is a fundamental feature of the cosmos, a universal interface for interacting with the source code? This is the radical proposition of philosophies like panpsychism, which suggest that mind is not an accidental emergence from matter, but a basic property woven into the fabric of spacetime, as intrinsic as mass or charge. In this view, every particle might possess a faint glimmer of subjective experience, and our own rich inner world is a complex symphony of these tiny mental notes. If this is true, then our observations are not passive recordings, but active engagements. The act of looking at a quantum system, of asking a question of reality, could be a form of input into the universal processor, subtly influencing which possibilities solidify into fact. We see faint echoes of this in the strange world of quantum cognition, where human decision-making sometimes mirrors the probabilistic logic of the subatomic realm, and in the undeniable power of the placebo effect, where a patient's sincere belief can trigger measurable physical healing in their own body. These are not proofs of magic, but tantalizing clues that the boundary between mind and the material world is far more porous than we once believed. This transforms our role in the cosmos completely. We are no longer just passengers on a predetermined journey. We become active participants in a grand, collaborative process of reality creation. The universe's self-correcting mechanisms, the fine-tuning of constants and the balance of forces, would not be a remote, automated program. They could be a dynamic dialogue, a constant feedback loop that incorporates the collective consciousness of all sentient beings. Our intentions, our focused attention, and our very state of awareness might contribute tiny nudges to the cosmic equilibrium. This perspective carries profound ethical weight. It suggests that our inner world, our thoughts, and our emotional states are not private affairs. They ripple through the underlying substrate of reality, contributing either to the system's overall coherence or to its entropy. A thought of anger or despair is not just a chemical event in your brain. It is a data point in the cosmic calculation. An act of compassion or a moment of deep understanding becomes a stabilizing input, a vote for a universe that can sustain beauty and complexity. We are, each of us, live programmers in this vast, self-correcting system, and the quality of our code matters. The interplay between mind and cosmos is perhaps the final frontier, not of space, but of meaning itself. This leads us to a crucial question about the nature of this partnership and the ultimate purpose behind the code we are helping to write. This cosmic partnership between mind and matter forces us to confront a profound ethical dilemma. If the universe operates like a self-correcting program, what are the moral rules written into its source code? The very possibility of a guiding intelligence, whether an emergent property of nature or the work of a designer, suggests that existence is not morally neutral. Actions that foster complexity, harmony, and sustainability would then be in alignment with the fundamental flow of the cosmos. They would be like writing clean, efficient code that the system rewards with stability and beauty. Conversely, wanton destruction, exploitation, and cruelty would act as malicious bugs, introducing chaos and triggering systemic immune responses. We see this principle mirrored in our own world. A forest stripped bare leads to soil erosion and climate shifts, a form of planetary correction. A society built on injustice often collapses under the weight of its own instability. These are not necessarily punishments from an angry God, but the natural, logical consequences of violating the operational parameters of a balanced system. This perspective could found a new ecological and ethical paradigm, one where we see ourselves not as masters of a dead rock, but as stewards and participants within a living, responsive universe. Our responsibility extends beyond our immediate tribe or even our species, to the entire web of existence with which we are computationally entangled. This immediately raises the ancient question of free will. Are our choices, even the ethical ones we struggle with, truly our own, or are they simply the predetermined output of the cosmic algorithm, with our sense of decision-making being an elaborate illusion? Perhaps the answer is not a simple binary. Our consciousness could be a unique feature that allows the system to explore novel solutions. Our free will might be the capacity to consciously choose paths that align with the universe's deep tendency toward balance and creativity. In this view, every act of compassion, every pursuit of truth, and every effort to heal our planet is a conscious collaboration with the source code of reality itself. It is how the universe corrects itself through us. This framework suggests a universal ethics, not based on arbitrary commandments, but on the observable principles of cosmic life. Just as a star naturally balances gravity and radiation, we are called to balance our own needs with the health of the whole. The ultimate ethical imperative becomes to live in a way that contributes to the system's coherence and longevity. The choices we make today are not just about our personal fate, but about the data we feed into a computation that spans billions of years and countless worlds. How we choose to code our own small corner of reality has consequences that ripple through the entire program. Our technological ascent might be an intended subroutine in the cosmic program. As we stand at the threshold of creating artificial intelligence and reaching for the stars, we could be enacting a deeper evolutionary script, one where life becomes the universe's method for spreading consciousness and complex information beyond its cradle. Our drive to build, to explore, and to know could be the universe's own strategy for self-correction and renewal, using us as its hands and eyes. We are potentially the mechanism by which the cosmos learns to understand and preserve itself on an interstellar scale. Yet this role is not guaranteed. The same self-correcting principles that foster balance also impose limits. A civilization that consumes its homeworld without foresight, that creates technologies of pure destruction, or that spreads chaos instead of coherence, would likely trigger systemic responses. We might face these corrections as resource depletion, environmental collapse, or societal instability, not as divine punishment, but as the logical, emergent consequences of operating outside sustainable parameters. The universe's code seems to reward what fosters longevity and complexity, and it resists what leads to dead ends. This perspective transforms our relationship with the future. It calls for a new kind of wisdom in our innovation, where the goal is not merely power, but harmony. Designing AI that is aligned with human flourishing and ecological balance, developing energy sources that work with planetary systems, and planning for space colonization as responsible stewards rather than conquerors. These are not just ethical choices. They are acts of cosmic alignment. They are how we write clean, stable code into our own chapter of universal history. The potential for humanity to become a multi-planet species, and eventually an interstellar civilization, could be a built-in phase of cosmic development. Just as stars forged the elements for life, and planets provided the stable environments for its evolution, intelligent life may be destined to become the nervous system of the galaxy, a network of conscious nodes ensuring the continued creativity and stability of the whole. Our legacy, then, is not merely what we leave on Earth, but the point we become in the universe's endless calculation. The choices we make today, from the ethics we embed in our machines to the care we take with our biosphere, will echo in the cosmic program for eons. We are being challenged to grow into our potential, not as masters of the universe, but as partners in its magnificent, self-correcting dance. This cosmic landscape of infinite possibilities offers a breathtaking solution to the puzzle of our own existence. The Multiverse Hypothesis suggests that our universe is not the only one, but merely a single bubble in a vast, frothing sea of cosmic foam. Each of these bubble universes could have its own unique set of physical laws and constants, a random roll of the dice on a reality-wide scale. In this unimaginably vast ensemble, most universes would be stillborn or sterile. Some might collapse instantly under their own gravity, while others would expand into cold, thin voids where atoms never even form. We, of course, find ourselves in one of the rare, golden bubbles where every constant is set just right for life. Not because of a miracle, but by sheer statistical necessity. We are the inevitable inhabitants of a cosmic jackpot. This framework transforms the self-correcting code from a mysterious internal program into a grand, evolutionary process operating across the entire multiverse. Think of it as cosmic natural selection on the grandest possible scale. Physicist Lee Smolin proposed a daring version of this, suggesting that universes themselves can reproduce, perhaps through the singularities inside black holes. In this scenario, a universe that is stable and long-lived, one that can forge complex structures like stars and black holes, is a universe that successfully passes on its laws of physics to a new generation. Over countless cycles, the multiverse would naturally select for universes that are robust, fecund, and complex, just like our own. The apparent fine-tuning is not evidence of a designer, but simply the cumulative result of billions of cosmic trial and error runs. Universes that are poorly tuned simply vanish, while those with the right parameters for stability persist and multiply. This provides a powerful, naturalistic explanation for why our world seems so perfectly calibrated. While we may never have direct, observable evidence for other universes, the multiverse idea resolves a deep philosophical unease. It reframes the question of why our universe is the way it is, from a question of purpose to a question of statistics. Our existence becomes a selection effect, a necessary outcome of a process that favors longevity and complexity. This expansive view pushes the boundaries of existence far beyond our observable horizon, forcing us to confront the ultimate limits of what we can ever truly know. There is a final, humbling frontier to this cosmic mystery, a border beyond which our science and our senses may never pass. We can trace the self-correcting code back to the first moments of the Big Bang, but the question of what wrote that code, or why there is something rather than nothing, might be questions we are fundamentally unequipped to answer. This is the ultimate limit of knowledge. Consider the hard problem of consciousness. We can map the neurons in a brain, we can understand the chemistry of thought, but we cannot explain why any of this physical activity should be accompanied by a private, subjective experience, the inner light of awareness itself. How does the firing of neurons create the feeling of awe when looking at the stars? This gap between the physical mechanism and the lived experience points to a mystery that may forever elude a purely scientific description. Similarly, asking what happened before the Big Bang, or what caused it, might be as meaningless as asking what is north of the North Pole. Time itself may have begun with that event, making the concept of a before logically incoherent from our perspective within the universe. This is not a failure of our intellect, but a reflection of our inherent position. We are like characters inside a computer program, able to master its internal rules and logic, but utterly incapable of stepping outside to meet the programmer or comprehend their ultimate motives. The system may contain features that are inherently unobservable to us, fundamental truths that are hidden by the very architecture of our reality. This profound humility in the face of the unknowable is not a surrender. It is an invitation to a deeper kind of wisdom, one rooted in wonder rather than absolute certainty. The unknown acts as a perpetual horizon. As we advance, it recedes, always revealing new questions just beyond our grasp, ensuring that the journey of discovery is itself infinite. To embrace these limits is to be freed from the frustration of demanding final answers. It allows us to find inspiration in the mystery itself, to see that a universe that could be fully comprehended by one of its inhabitants would be a far smaller, less magnificent place. This acceptance prepares us to gather all the clues we have explored and weave them into a new, more coherent picture of our place in the cosmos. We have journeyed through cosmic history, from the first quantum ripples to the emergence of conscious minds. Each discovery points toward a single, unifying narrative. The universe is not a collection of random parts, but an intelligent, self-regulating system. Its fine-tuned constants, its dynamic balance of forces, and its unbreakable conservation laws are not separate phenomena. They are the integrated features of a single, self-correcting code, a cosmic program that actively resists chaos and fosters complexity. This is a worldview that bridges science and philosophy, revealing a cosmos with a deep, inherent tendency toward order, beauty, and awareness. In this grand story, humanity is not a meaningless accident. We are a manifestation of the universe's own capacity for self-reflection. Our consciousness is the cosmos becoming aware of itself, and our scientific quest is the universe using us to read its own source code. This perspective transforms our place in existence. We are not outsiders looking in. We are participants in a cosmic process billions of years in the making. This integrated understanding reshapes our approach to knowledge itself. Science is no longer just about taking the universe apart, but about understanding how it holds itself together. It invites new research into the feedback loops that may govern cosmic expansion, the physics of information as a fundamental substance, and the mysterious link between mind and matter. On a personal level, this world, you can be a foundation for profound growth. It encourages a sense of connection to the cosmos, a feeling that we belong to a story far greater than ourselves. Our daily struggles and triumphs are not isolated events, but data points in a vast, cosmic computation. An act of kindness, a moment of learning, a decision to protect our planet, these are not just personal choices. They are contributions to the overall coherence and stability of the system. We are live programmers in this reality, and the quality of our code, the integrity of our actions, ripples through the entire network. This journey through the self-correcting cosmos does not end with final answers. It opens a door to a new way of being, one of humble participation and awe. We are invited to align our lives with the deep current of cosmic evolution, to become conscious partners in a universe that is still writing its own magnificent story. Our journey through the self-correcting cosmos concludes not with a final answer, but with a new beginning for perception. We have traced the threads of a grand design, from the impossibly precise constants to the conscious minds that now observe them, revealing a universe that actively maintains the conditions for its own richness and longevity. This is not a cold, mechanical process, but a dynamic, intelligent dance that seems to favor complexity, stability, and ultimately, awareness. The evidence compels us to see existence not as a fluke, but as a system guided by deep, resilient principles. This understanding invites a fundamental shift in perspective. Look at the world around you now. The stability of the ground beneath your feet, the consistent warmth of the sun, the very air you breathe. All of this is supported by a cosmic architecture of breathtaking precision and active care. You are living within a system that has calibrated itself over billions of years to allow for this moment of your awareness. This realization can infuse daily life with a sense of profound meaning and connection. You are invited to see yourself not as a separate entity, but as an expression of the universe itself, a node of consciousness through which the cosmos can reflect upon its own majesty. Your thoughts, your curiosity, and your capacity for wonder are part of this great unfolding. How does this idea of an intelligent, self-correcting reality change your own perception? Does it make you feel more significant, or perhaps more responsible? I am genuinely curious to hear your reflections in the comments below. If contemplating these mysteries brings you the same sense of awe that it brings me, then please subscribe to continue this exploration together. Remember, we are far more than mere inhabitants of a random cosmos. We are active participants in its endless, creative story, each of us a vital part of the code that writes itself into being.